This is Calculus Homework 1.1D, and we're going to be doing problems 3, 7, and 11. Problem number 3, we're asked to simplify it, and even though it tells us we should simplify it by factoring and canceling, we should be able to see that even if they don't tell us, because we have a linear on top and a quadratic on the bottom, and so it should make us think, well, if we factor this quadratic into a linear and a linear, we might be able to cancel the linear terms. So we're going to leave the numerator the same, and we want to factor the denominator. And there's a cute trick you can do here, which is that the only way it'll end up canceling with the top is if one of the factors is x minus 5. And that makes it a lot easier to factor, because you just think, well, what binomial factor can multiply to make x minus 5? And to get you 2x squared, x has to multiply with 2x. X times 2x will get you the 2x squared. And to get the positive 5, negative 5 will have to multiply with negative 1. So negative 5 times negative 1 is positive 5. X times 2x is 2x squared. Now we do need to check and make sure that this gives us the correct middle term. We can do that by multiplying the the outside terms and the two inner terms. X times negative 1 is negative x. Negative 5 times 2x is negative 10x. And that adds up to be negative 11x. So this is factored correctly. We got our 2x squared minus 11x plus 5, and now that it's factored, we can cancel out the x minus 5 term from both the numerator and the denominator, and what we're left with is 1 over 2x minus 1, and these are equal to each other as long as x isn't equal to 5, because we canceled out the x minus 5 term. This one is undefined at x equals 5, this one is defined at x equals 5, but everywhere else they'll be equal to each other. Number 7 is another one we're supposed to simplify, and when you see a square root minus or plus something and a linear term, you should think, oh, maybe I can multiply by the conjugate to cancel out the square root term and try to cancel it out. The way multiplying by the conjugate works is to keep the fraction the same, you have to multiply by the same thing in the numerator and the denominator, and to get rid of the square root, we multiply by the conjugate. And what the conjugate is the first term stays the same, so it's still square root of x, and then instead of minus 3, it will be plus 3. If this had been plus 3, we would multiply by minus 3. We'll see why in a second. If we multiply by square root of x plus 3 in the denominator, we also need to multiply by square root of x plus 3 in the numerator to keep the fraction having the same value. In the numerator, we're not actually going to multiply this out. We're just going to leave it written as x minus 9 times square root of x plus 3. And you'll see why in a second. We're going to get something to cancel out there. In the denominator, we are going to multiply this out. This is a binomial times a binomial. So the first thing multiplies. Square root of x times square root of x is x. Then square root of x times 3 is 3 square root of x. And negative 3 times square root of x is negative 3 square root of x. So 3 square root of x minus 3 square root of x is 0. That all cancels out. And so the only other term that will matter is the negative 3 times positive 3, which is minus 9. That's why the conjugate works, is because the middle terms with the square roots cancel out. And now we'll notice that the x minus 9 can cancel out with the x minus 9, and so we're left with square root of x plus 3 as our final answer. Now, these two are always going to be equal to each other, except when x is 9, because when x is 9, this one is undefined and this one is not. In number 11, we are trying to simplify this complex fraction. And when you see a complex fraction, you should just be thinking, what can I do here? And the first thing I notice that I can do is I can combine these two fractions. They're adding together, and we learned in middle school in Algebra 1 how to combine fractions. We need fractions to have a common denominator to be able to add or subtract them. So if I see fractions I can add or subtract, I'm going to try to do that. To get a common denominator, I need to find the least common multiple of these, and the least common multiple is going to be 3x. I can get to that by multiplying this one by 3 over 3, and by multiplying this one by x over x. Notice that I'm multiplying by 1, so I don't change the value of the fractions. So this becomes 3 over 3x plus x over 3x, and it's all still being divided by x plus 3. I can combine these now. This is going to be x plus 3 over 3x, all divided by x plus 3. So the next thing to notice is that we have a fraction divided by something. To simplify, dividing is the same as multiplying by the reciprocal, and so I'm going to take this fraction and rewrite it as x plus 3 over 3x, and instead of dividing by x plus 3, we're going to multiply by 1 over x plus 3. And I could multiply this out, or I could just notice that I'm multiplying and dividing by the same thing, and so this term will cancel, leaving me 1 over 3x, as long as that term I canceled out isn't 0, because I would be dividing by 0. So as long as x is not equal to negative 3. So there is a domain restriction on that one as well. Hope that helped.